One of the things that commonly creates bugs in web applications is inconsistent data. For example, your user sign-up logic can have multiple inserts involved in creating all of the data that is necessary for the user to be onboarded to your application. Your code creates a row in the users table to create the account and then uses the result of that to create the user's profile in child tables. If those secondary inserts fail, the user account will only be partially set up, and it may result in errors or worse, a blank page with no feedback to the user. The fix to this problem is to use database transactions. So if any part of your multi-step change fails, everything will be cleaned up correctly. In this video, we'll show you how to wrap your changes in transactions to keep your data consistent. Hello developers and welcome to the PHP Architect channel. I'm Scott Keck-Warren and today we're covering database transactions, what they are, why they matter, and how to use them in both raw SQL and Laravel's ORM. If you're new here, we cover topics related to the PHP ecosystem. Smash that subscribe button so you don't miss our videos. At a very basic level, a database transaction is a group of one or more SQL operations that are treated as a single unit of work. You get to tell the database start the transaction, run your inserts, updates, or deletes, and then either commit to save the changes or roll back to undo the change in the group. The database engine will guarantee that the changes will either all succeed together or all disappear together with no middle ground where half of your changes are persisted and you end up with missing user data. At a conceptual level, database transactions follow a set of rules known as ACID. It's not something you need to worry about memorizing, but it helps explain what transactions promise to you as a developer. Now, ACID is an acronym that stands for Atomicity, Consistency, Isolation, and Durability. Atomicity means the transaction is all or nothing, so every operation inside the transaction either completes successfully or the entire group is rolled back. Consistency means the database always moves from one valid state to another. If you have foreign key constraints or unique indexes, the database will enforce those rules at each step of the transaction before allowing the transaction to commit. Isolation means transactions running at the same time do not interfere with each other. One user's registration flow doesn't see the partial data of another user's registration that hasn't been committed before the transaction started. And then finally, durability means that once a transaction is committed, it will exist for all time, even if the server crashes. So let's start out by looking at the code that can cause a mess with our user registration. Here is a simplified registration flow that inserts into 4 tables, one at a time. Now, if the second insert fails, the users row has already been committed, and you now have a user who exists but is missing some of their data. A transaction solves this by grouping all 4 inserts into a single unit. Let's rewrite our registration flow using transactions so we don't need to worry about this type of bug. After this word from our partners. Production monitoring can be complicated. There are tons of tools and techniques, but you just want to know your app is up and your users are happy. When your customers encounter a problem, you need clear, actionable intelligence, not walls of charts and reams of logs. That's why they built Honeybadger, the monitoring tool you've always wanted, a tool that's there when you need it and gets out of the way when you don't. With Honeybadger, you'll know when critical errors occur and which customers are affected, respond instantly when your systems go down, improve the health of your systems over time, fix problems before your customers can report them. Honeybadger is the application health monitoring tool built for you, the developer who cares about quality product and happy customers. Start monitoring today at honeybadger.io. It's free to get started, and setup takes less than 5 minutes. Once again, that's honeybadger.io. In most SQL variants, you start a transaction with a start transaction command and you finish it with a commit command. If something goes wrong, you can roll it back to undo everything. This is the user registration wrapped inside of a transaction. If any of these inserts fail, you can issue a rollback instead of a commit, and every row changed inside the transaction disappears as if it never happened. In a lot of cases, your application might throw an exception, which will automatically trigger a rollback. This example was written specifically to be run in a MySQL console, but it's fairly similar between vendors, even if they generally handle variables inconsistently. But you should be able to port this to your database of choice without too much effort. Now, if you're using a framework, you generally don't need to and shouldn't write raw SQL for your transactions. For example, Laravel gives you the DB transactions function, which wraps your code into a transaction automatically. If any part of this throws an exception because of a missing column or a constraint violation, Laravel catches the exception, rolls back all of the inserts automatically, and then rethrows the exception so your error handling can deal with it. The user's row is gone, leaving you with no inconsistent state. So if you're not careful, you can shoot yourself in the foot. with transactions. And so here are some common gotchas for you to watch out for. First of all, do not put external calls inside of a transaction. Performing actions that perform side effects like dispatching an email inside of a transaction is a common mistake. If you roll back the transaction, the email has already been sent and cannot be unsent. Move any external calls outside of the transaction by inserting the data first, committing the results, and then doing the external call. Now, it is possible to nest one transaction inside of another transaction, but different databases behave differently based on their implementation. Your transactions might run fine in Postgres locally, but then fail when you attempt to do the same thing in MySQL in production. I highly recommend you do not nest transactions. Finally, you can forget to commit. If you start a transaction and never call commit or rollback, the transaction stays open until the connection closes. And while it's open, any locks it holds will remain in place, which will cause mysterious slowdowns in your application as other requests attempt to access the same data your transaction is accessing. Not that I know from experience, but it does happen. Always make sure every start transaction has a matching commit or rollback so you don't cause this problem. As a brief recap, transactions group multiple database operations into a single all or nothing unit. ACID guarantees atomacy, consistency, isolation, and durability. Use the start transaction with a corresponding commit or rollback. Your framework should handle commit and rollback automatically based on the exceptions. Keep transactions short. Do not put HTTP calls or email sending inside of them. Be aware that nested transactions behave differently depending on your database engine. Thank you so much for watching our video today. Have you ever been bitten by a partial write bug where half the data made it to your database and the other half didn't? I'd love to hear your war stories in the comments. If this video helped you understand transactions better, hit that like button and share it with a teammate who might be writing multiple table inserts without transactions right now. And if you want more content like this, subscribe so you don't miss the next one. This is Scott Keck Warren for the PHP Architect channel signing off and remind you to keep watching, keep coding, and keep reading.